Let's continue with question number 5 of the race number 0 of the Secureum Bootcamp. And this one is quite interesting because now it's all about delegate-call. As you can see here, all of the options have to do with delegate-call. There's a delegate function, which is external, has no modifiers, anyone can call this, and it makes an address, it makes a delegate call to an arbitrary address that can be passed in here. So before we know why this is really bad, we should maybe have a quick review of what delegate call even does. So let's say we have an account with some address. Let's say we have the address 123, and this is our contract. This is the test contract that we just looked at. So this test contract, it has many values associated with it. For example, the value that it holds in ether, the storage, all the storage values that it's holding, and it also has code. So when you now call this delegate function, what happens is that all of this stuff, all of this data, is put into an EVM context. So let's call this the EVM context. Which means that an EVM is started, EVM, which has access. Obviously it needs to load the code, so it knows what to do. The code has access to storage, the code has access to the value, to read it. And obviously the EVM comes with some own stuff, because every time you start an EVM you get some fresh memory, you get a fresh stack, and if this contract was called from the outside, because we called delegate call the function, so there will be some call data that comes into this context. So this is basically what happens when you execute a function within the EVM. What happens is that we build this EVM context. The EVM comes with a stack with memory, the code has access to all of these things. And then if we make a call, an external call to another account, let's say it's an account 345. Now if this is an EOA account where you have a private key for accessing the value of this, it pretty much doesn't have anything more than the value. But if it is a contract, it again has its own storage and its own code. So if this would be a normal call, then this would basically start an entirely new EVM context for this separate contract. You would again have an EVM. This would again load the code into the EVM. It has access to its own storage. And then once it's done, it returns the return value back to the caller. But during a delegate call, this is not what happens. What happens during a delegate call is that we take only the code and then we start the EVM context for the caller. So we again take the 123 account. We again have the value, the storage, and the code, and we start this EVM context. And the difference now is that during this delegate call we don't use the original code of that address. Instead, we take the code from the address that we're delegate calling to, we take that code and run with it instead. So now the EVM here takes this code, but still has access to these storage variables and that value, it gets once again a fresh memory. So these memories are completely different. It gets a fresh stack and all that. But the code that is now running here is running as if this code was the code of the 123 address. This code now has access to the storage and, well, everything else that belongs to that account. It can now act as if it is this account. And that is what makes this so dangerous, because if we can make this contract 123 arbitrarily call any other contract delegate call, we should correct this here and make it a delegate call. This delegate call to this code, and because the address that we're specifying here is arbitrary, this could be any account of any code. It could be our code, it could be our malicious code. So then it would load our malicious code here into this context that belongs to this account, to this test contracts account. And now we can run our code, and our code can change all the storage variables that it wants to change. And that is why this is so dangerous. So let's go back to the options. And the option number A is there is a potential control delegate call risk. So yes, we have a delegate call. We have a delegate function. It is external. There is no checks, no authentication to make sure that not only specific people, like for example only administrators, have access to this delegate call. And yes, that I would call it a potential control delegate call risks. Because what could happen now is that, let's see here for example, this only admin function modifier. We are to assume that other required functionality is correctly implemented. So let's assume that this only admin modifier is actually correctly implemented. This means there's, here we can't see it, but there is some storage variable for storing the address of the admin account. And then this basically checks that the message sender is equal to this storage variable that holds the administrator. When we now put the address of a malicious code of a contract that holds malicious code in here, and we delegate call to it, that means our code will now run within the context of the test contract, and we would be able to update the storage variable that holds the admin address. And then we could use this contract test as if we are the admin, because we've basically taken it over. And that is what makes delegate call so risky. So option B, delegate call return value is not checked. That is correct. Just like in the previous question, we had .call, the low-level call, and it returned two values. One is the Boolean for the success that the call worked, and the other one is the data that is returned for the call, which is a bytes array. And neither of these are checked, and we should at least check the success of this delegate call. In the usual case, you should at least check the success. So that is a potential security risk again. And then C, delegate call, the delegate function may be missing only admin modifier. So yeah, having a delegate call exposed to everyone on an external function without any checks is definitely bad. Having an only admin modifier would be better if only admins would be able to do this. So I would say yes, but I would also argue that not even admins should probably be this powerful to just randomly execute other code. It's not very decentralized, because they could just take over and do whatever they want with this entire thing without the users knowing anything about it. So yeah, it's probably missing, but they probably shouldn't have it either. And then lastly, delegate does not check for contract existence at address. So basically what this is saying is that we could pass in an address here where there is actually no contract. So we could delegate call to an account where there is no code. So why is this a problem? Because the expectation here is, at least with delegate call, the expectation is always that we delegate calling to another contract, because what's the point of the delegate call then? So this check is missing because if the EVM doesn't check whether the target that you're delegate calling to, or even normal calling to, has even any code to execute basically. And you could .call an EOA account, an account with a private key, so it definitely does not have any code associated with it. And when you .call this EOA account, it would pass. And you might be surprised, but then you have to remember that when you send value to an EOA account, the best practice is still that you should use .call with a value and empty call data to send it there. So it is only logical that calls to an address that doesn't have code needs to pass, otherwise you wouldn't be able to send value to those addresses, because an EOA account definitely does not have a fallback or a receive function. It's just empty code, but empty code always passes basically. Empty code always succeeds. It doesn't return anything, it doesn't do anything, it just succeeds without complaint. And because in delegate call there's definitely an expectation that there should be code to where we're calling, we should first check that this address that we're calling to actually contains any code to execute. And only if we check that, then we should actually execute the delegate call. So yeah, all of the options are correct, and that's it.